These are the audio notes on pH. As mentioned in the previous notes, a pH at room temperature of anything that's below 7 is an indicator that it is an acid. Above 7, on the other hand, would make it a base, which means 7 is neutral. Water is neutral. Some ionic compounds are neutral as well. For example, salt water, NaCl, is neutral. We don't go over how the pH scale is derived. Again, that's mathematically based upon things that we cover in AP chemistry or you would cover in a college chemistry course. But typically, the pH scale runs from 0 to 14. However, you can have things that are lower than 0 on the pH scale. We will be working with such things. We will have things that are above 14 on the base scale as well. So pH itself stands for power of hydrogen. That's why the H is capitalized and the P is lowercase, the power of hydrogen. If you recall from the previous notes, how much hydronium ion you create in solution is how acidic something is. So the pH is able to measure that. The more the acid ions that are present, the lower the pH is. Think about that for a second. If water is neutral at 7, the further away you get from water, the more acidic you become. An example I give here is something with a pH of 2 has 100 times more acid ions than something with a pH of 4. If you've learned in math classes of the logarithm scale, maybe like the Richter scale for earthquakes is a power of 10 scale, so an earthquake of magnitude 7 is 10 times more powerful than 6. pH scale is similar in power of 10. However, a pH of 2 is more acidic than a pH of 4. I'd like to go over that with you just a little bit more here on the smartboard as well. So remember, below 7 is an acid, above 7 is a base. 7 itself is considered neutral. Now, you have your 6, 5, 4, 3, 2, 1. To simplify this, let's say that there's 1 part acid at a pH of 7, which could be true as long as there's also 1 part base, because the two balance each other out. That would give you neutral. A pH of 6 would have 10 parts acid, because for every 1 on the scale, there's a 10-part difference. A pH of 5 then would have 100 parts acid. A pH of 4 would have 1,000 parts acid. pH of 3 would have 10,000 parts acid. pH of 2 would have 100,000 parts acid. A pH of 1 would have 1 million parts acid. A pH of 0 would have 10 million. Again, I'm making out the scale of starting with 1 part acid for neutral 7. However, I want you to see that power of 10 scale in work. There is a big difference between something that is a pH of 2 and a pH of 3. I mean, if we look at those two, there is a 90,000 difference between those. A pH of 6 and a pH of 7, however, there's only a 9-part difference. The same thing works in the other direction. 8, 9, 10, 11, 12, 13. Where if I were looking at bases, if there's 1 part base at pH 7, remember the acid and the base just balance each other out. That means at a pH of 8, there's 10 parts base. And then at a pH of 9, that would be 100 parts base. And a pH of 10, that'd be 1,000. So again, the pH scale, and that continues on, is a logarithmic scale. That's what I'm trying to demonstrate with this slide right here, is to show you that. The further away you get from 7, the more acidic you become if you go lower on the scale, or the more basic you become the higher you go on that scale. 7 is neutral, where the amount of acid and the base balance each other out. But if you have more acid than base, you're going to be here. If you have more base than acid, you're going to be over here. And that power of 10 scale is how the pH scale was derived. Most of the solutions that we're going to be working with are clear. And yet we need to know, are they acids, are they bases? We need to know information about these things. So an indicator is used in acid-base chemistry. An indicator helps tell us what do we have. It will give a color change. So different colors can tell us what we're working with. We're going to be working with 2 indicators in the next 2 class periods. Some indicators will help you tell what the pH is. And on Wednesday and Thursday of this week, you'll be doing a colorful chemistry activity to show what's the pH of a solution by adding something to it. Others tell you, is it an acid or is it a base? And we'll be using that indicator on the following class period, the 27th or the 30th. So the indicator that we're going to be using for our first lab activity is going to be called universal indicator. Now, the universal indicator gives a wide range of colors for the pH. And actually, if you're doing a lab activity, there's probably a small index card at your lab bench that shows things like purples are for a pH of 10, 11, 12. Blues are more like 10. Green is a 7. Reds are a pH of 3. So there's a lot of colors. So if you just squirt some universal indicator into a clear solution, that color will tell you, is it acidic, is it basic, even how acidic it is, which is sometimes important. Because just knowing it's an acid, well, an acid with a pH of 6 isn't that dangerous, but an acid with a pH of 2 is very dangerous. Remember that power of 10 scale I just went over. The second indicator, one of my favorite words in chemistry, it is called phenolphthalein. Phenolphthalein, if you add it into the solution, will tell you whether or not something is an acid or a base. And some people would say to themselves, well, that's not very important. Who cares about that? But we are going to use phenolphthalein when we deal with neutralization reactions. Recall that you've learned how to write neutralization reactions. We're going to be neutralizing acids with bases in a process called titration, using a piece of glassware called a burette. And we want to know the instant something changes from acid to base. So phenolphthalein in the presence of acid is clear. In the presence of a base is a light pink color. Now, more base makes it more of a dark pink, kind of magenta color. So when you do your titration lab later in the week, you are going to have a clear solution that you're adding base to. And the moment the amount of base balances the amount of acid, it's become neutralized. One drop beyond that, the solution turns very light pink to tell us, hey, we've reached the end point of this titration. If you were to go beyond light pink, then you're overshooting your mark and you're actually making it a little bit more basic than it needs to be. I have a couple other slides on here dealing with household indicators because we can actually use cabbage and things like that to make our own indicators at home. However, I'm going to stop here with the audio notes because you need to know 2 things from the notes today. What is the pH scale? So how do I know acids from bases, kind of that power of 10 scale? And then secondly, chemical indicators, things we'll be using in the lab to help tell us what are we working with.